Okay, so this problem is another momentum problem. And in this one, we've got a little ball of 5 grams moving at 20 centimeters per second. So let's draw a little ball here, and let's call it ball A. And it's moving in this direction at 20 centimeters per second. And the mass of ball A is 5 grams. Okay? And it actually hits another ball, ball B. And ball B is traveling in the same direction, but only at 10. Okay? So not as fast. But it says that ball B is actually twice as big. So we can say this is, not only is it going 10 centimeters per second, but its mass is also 10 grams. Now, after they collide, so they bounce away from each other, the first one, A, is now traveling with a speed of 8 in the same direction. So let's put an after here. And here is A. It's traveling in the same direction, but now only with 8 centimeters per second. Okay? Question is, how fast is now B going? Question mark. Okay, so this was before. Once again, all of these momentum problems need to be solved with the concept of conservation of momentum. Initial momentum equals final momentum. In this case, we have two masses before and after. Okay, there's before and after. So it's quite easy. I just go MA VA plus MB VB is equal to MA VA. Now, I'm not going to use double subscripts. So in order to denote final velocities, I'm going to use a prime, which is that tick there, plus MB VB prime. Okay? Now, if I plug some values through here, before I do, actually, honestly, I don't like putting in numerical numbers before I actually solve for my desired variable algebraically first. So what am I looking for? Well, I'm actually looking for VB prime. This is VA prime, and this is the one I'm looking for. Okay? This 20 up here was VA, and this 10 was VB. Okay? Therefore, since I'm looking for this value, let me solve for it algebraically. No problem. I say MAVA plus MBVB minus MAVA prime all over MB is equal to VB prime. And now I can plug in my numbers. What's MA? Well, MA is 5 grams, so that's just 0.005 kilograms. And by the way, just to let you know, I'm solving this in terms of grams and meters per second. But honestly, if we leave the units as they are, which let's just try it this way. I know we're using non-standard units, but basically what's going to happen is that our answer is just going to come out as centimeters per second. So let's just go with the units that they're giving us, although they're not standard. So 5 times VA, which is 20, plus 10 times 10, Okay, so there's the 10 here and the 10 here. And then minus ma, which is 5 times the final velocity, which is 8, all over b, which is 10. So let's get our trusty calculator out. And let's go, well, 5 times 20 is 100, plus another 100, that's 200, minus 40, so that's 160. 160 divided by 10 is 16. I don't even need a calculator for all that. So our final answer is 16 centimeters per second. And that's it. We're done. So this was 16 centimeters per second. Final answer. Hope you enjoyed it. See you next time.